I want you to walk into your kitchen, open up your pantry, and just find a packet of powdered drink mix. Something super simple like cherry Kool-Aid. Hold that little paper envelope in your hand and really look at it. Because what if I told you that the underlying foundational logic behind that tiny packet of colored powder is the exact same logic currently driving the collapse of international nuclear arms treaties?
Right.
And what if I told you that that same powder explains the deployment of the most terrifying hypersonic weapons ever conceived by human minds? And strangely enough, it holds the key to a 100-year blueprint for literally bringing the dead, hellish planet of Venus back to life.
It sounds completely absurd when you put it like that. A drink mix and planetary engineering.
Yeah.
But the connective tissue between those things is absolutely real. And it revolves around a single, terrifyingly simple physical concept, which is the concentration of potential energy. Today, we are unpacking a pair of geopolitical and strategic essays written in 2026 by Zachary David Enfield.
Fascinating stuff.
Truly. He maps out how the recent absolute free fall in space launch costs has done two things simultaneously. First, it has resurrected an old Cold War science fiction concept known as rods from God, which is a system of orbital kinetic bombardment creating an unprecedented strategic nightmare.
Right.
And second, he outlines how that exact same technology, point for point, serves as the engine for the Centennial Collapse, which is a mathematical model to terraform a planet.
And before we get completely lost in the physics of space weapons and dead planets, we really need to set the table for you, our listener. The source material we're pulling from today relies heavily on some very intense, very real-world geopolitical events.
Yeah, that's crucial context.
Specifically, Enfield's essays reference the escalating conflicts in the Middle East throughout 2025 and early 2026 involving the U.S., Israel, and Iran. I want to make it unequivocally clear that our mission on this deep dive is not to take any political sides.
Absolutely not.
We're not here to endorse any specific geopolitical viewpoints or foreign policy decisions.
Hmm.
The world is tense enough. Our focus today is strictly impartial. We are looking at the strategic, technological, and physical realities these essays present. We're looking at the math, the metal, and the mechanics.
Which is honestly the most productive way to analyze this, because when technology fundamentally alters the landscape of human capability, the politics will eventually follow the physics.
I completely agree.
And to understand the physics of what is happening in orbit right now, we actually have to step away from space entirely. We have to go back to that packet of drink mix. We have to go to the American Midwest almost a century ago.
I love this starting point so much. Picture the year 1927. We are in Hastings, Nebraska. It's a town sitting right out on the plains, roughly the geographic center of the continental United States. It's a place defined by wide open spaces and agriculture. And standing in his kitchen on West First Street is an inventor named Edwin Perkins. He had this product called Fruit Smack. It was a liquid concentrate, a heavy glass bottle of syrup that was expensive to ship and prone to breaking.
A logistical nightmare, basically.
Exactly. Perkins realizes this is incredibly inefficient. So he experiments. He removes the liquid, he dehydrates the sweetness, the flavor, and the entire potential of the drink down to a dry powder. He calls it Kool-Aid, originally spelled with an ADE.
The brilliance of what Perkins did wasn't culinary. I mean, it was logistical. He took an enormous amount of potential experience, gallons of sweet drink, and concentrated it into its absolute simplest, lightest, most deliverable form.
Just stripping away the dead weight.
Precisely. He removed all the heavy, unnecessary components. The end user just adds the ambient resource, which is water, and lets basic chemistry do the rest of the work. It is the purest form of concentrated potential.
Dehydrating potential. That is just such a fascinating way to look at it. But fast forward 15 years from that kitchen in 1927. We're in the thick of World War II. The United States military is facing a logistical nightmare of its own. They need to manufacture, store, and ship millions of tons of high explosives. And where do they look?
They look at that exact same Nebraska prairie outside of Hastings.
They do.
And they apply Perkins's logic, but on a catastrophic scale. In 1942, the military commandeers 49,000 acres of farmland southeast of Hastings to build the Naval Ammunition Depot, or the NAD. The scale of this place is something that is genuinely difficult to wrap your head around, even today.
Just to help you visualize this, 49,000 acres is larger than the entire city of Washington, D.C.
Easily. At its peak operational capacity during the war, this single inland facility produced and stored over 40% of the entire U.S. Navy's munitions.
40%.
Think about the sheer volume of firepower the Navy was expending in the Pacific theater alone. 40% of it was sitting in Nebraska. They built over 2,000 buildings. They constructed hundreds of massive reinforced concrete storage magazines shaped like igloos, and then covered them with earth so they would just blend into the natural rolling hills of the prairie grass.
And they had something like 10,000 workers operating there, right?
More than 10,000 at times, working around the clock in shifts. They laid down 207 miles of private railroad track just inside the boundaries of the depot to move bombs, mines, and torpedoes from the assembly lines to the storage igloos.
Which brings up the obvious question, why Hastings? Why put 40% of your naval firepower in the middle of a landlocked state, thousands of miles from any ocean? The text calls this the strategy of total invisibility.
It is the ultimate manifestation of hiding in plain sight. In 1942, the coasts were perceived as vulnerable to submarine attacks or aerial bombardment. Hastings was mathematically central. It was out of range of any enemy bomber.
Right, nobody could reach it.
But more importantly, it was completely ignored by the global consciousness. No adversary was looking at the cornfields of Nebraska for the heart of the American war machine. The military concentrated immense, world-altering, destructive potential into its simplest chemical form, and they buried it where no one expects thunder to live.
Where no one expects thunder to live.
Yeah.
But sometimes that thunder wakes up. The text mentions a specific incident in 1944.
Yes, there was a catastrophic accidental explosion in one of the loading plants. It detonated an unfathomable amount of high explosives all at once. The blast was so violent it tragically killed 9 men instantly.
Awful.
It gouged a crater into the prairie that was 500 feet across. The shockwave was so massive that it shattered windows and knocked people off their feet in Lincoln, Nebraska, which is 100 miles away.
100 miles away. If you're standing in a city 100 miles from an explosion and it knocks you down, that is not a factory accident. That is a seismic event. And yet, what fascinates me is the aftermath. The military didn't shut it down.
They couldn't. The war effort required it. They cleaned up the crater, rebuilt the necessary structures, and the depot just kept running. The thunder went back to sleep under the grass. The sheer geographical isolation of the prairie swallowed the anomaly.
And this is where the author Enfield makes a brilliant conceptual leap. He argues that this wasn't just a quirky historical anecdote about Nebraska. It was the birth of an institutional logic.
Exactly.
The United States military learned a very specific lesson. You can concentrate unimaginable power, strip it of all its complex moving parts, and hide it in an endless, empty geography where your enemies simply cannot reach it.
Which brings us to the present day, because the new prairie isn't the American Midwest anymore. We have run out of empty geography on the surface of the Earth. The new prairie, the boundless, empty space where we are now hiding concentrated power in plain sight, is low Earth orbit.
Low Earth orbit, which introduces a concept that sounds like it was ripped straight out of a comic book, Rods from God. The technical name is orbital kinetic bombardment. The text traces this back to a guy named Jerry Pournelle. Who was he, and how does he come up with this?
Jerry Pournelle is an incredibly interesting figure. He was a prominent science fiction author, but before that, in the 1950s and 60s, he was an aerospace engineer and operations researcher working at Boeing.
Okay.
He was deeply involved in Cold War strategic planning. Pournelle looked at the escalating nuclear arms race and the complexities of intercontinental ballistic missiles, and he proposed something called Project Thor.
Project Thor.
Oh, yeah.
It's an imposing name for what is fundamentally the most primitive weapon in the history of human conflict. It is literally just dropping a rock on your enemy from a very high place.
That is exactly what it is, a caveman standing on a cliff dropping a boulder on a rival. But Pournelle took that Paleolithic concept and scaled it up to the absolute limits of orbital mechanics. The brilliance of Project Thor is that it contains no explosives whatsoever, no nuclear material, no chemical warheads, no complex fusing mechanisms. It relies entirely on kinetic energy.
Let's talk about the physical object itself, because the specs are just wild. The text describes the weapon as a solid cylinder of tungsten.
The refined design calls for a tungsten rod that is 20 feet long and 1 foot in diameter.
Okay, if you're listening to this, try to visualize that. Next time you're driving down the street, look at a standard wooden telephone pole that is roughly 20 feet long and a foot thick. Now imagine that entire telephone pole is made of solid, unimaginably dense metal. What does something like that weigh?
Because it is solid tungsten, it weighs 24,000 pounds. That is 12,000 kilograms for a single rod.
24,000 pounds. So we have this 12-ton metal telephone pole floating in space.
Yeah.
How does dropping it actually cause any damage if it doesn't explode?
This is where we get into the pure, terrifying beauty of orbital physics. You have to look at the formula for kinetic energy. It's a foundational equation. Kinetic energy equals 1/2 mass times velocity squared.
I remember struggling through that in high school physics. KE equals 1/2 mv squared.
Most of us did. But when you apply it to an orbital strike, the numbers become catastrophic. You have a massive object, 12,000 kilograms. When it is released from an orbital platform, it doesn't just fall, it is accelerated by the Earth's gravity well.
Okay.
As it plummets through the vacuum of space and then hits the upper atmosphere, it continues to accelerate. By the time it reaches the surface of the Earth, that 24,000-pound rod is traveling at Mach 10.
Mach 10. That is 10 times the speed of sound. Something like 600 miles per hour.
Roughly, yes. When an object of that mass hits a solid surface at that velocity, the kinetic energy transferred at the exact moment of impact is staggering. It doesn't need high explosives. The sudden, violent deceleration of that mass releases energy equivalent to 11.5 tons of TNT.
Wait, I have to stop you there. Because when I think of objects hitting the atmosphere at Mach 10, I think of meteors. And meteors burn up. They turn into shooting stars. Why doesn't a 24,000-pound telephone pole just melt into slag before it ever reaches the ground?
That is the exact reason Pornell specified tungsten. Material science is the linchpin of this entire weapons system. Tungsten is an element with some very extreme properties. First, it is incredibly dense, about 1.7 times denser than lead. That gives you the massive weight required for the kinetic energy equation.
Right.
But more importantly, it has the highest melting point of all discovered elements. It melts at over 6,100 degrees Fahrenheit.
Which is hotter than the surface of some stars, isn't it?
It is incredibly hot. When any object re-enters the Earth's atmosphere at hypersonic speeds, it compresses the air in front of it so violently that it creates a superheated plasma shockwave. The aerodynamic friction is immense.
Why?
If you built this rod out of structural steel, it would liquefy almost instantly. If you built it out of aerospace-grade titanium, it would ablate, meaning the outer layers would literally burn and shed away as it fell, losing mass and aerodynamic stability. But tungsten endures. It gets white hot, yes, but it does not melt. It arrives at the target on the ground in the exact same aerodynamic shape it had when it left the satellite.
It arrives intact. And that physical integrity leads us into what the author calls the deep bunker problem. Because dropping 11.5 tons of TNT from space is impressive, but we have conventional bombs that can yield that much explosive force. Why go through the trouble of putting it in orbit? The text points to a very specific historical limitation of traditional warfare, using a real-world strike from 2025 as the prime example.
Yes, Enfield brings up Operation Midnight Hammer, which took place in June of 2025. This was a massive, coordinated strike by the U.S. Air Force targeting Iran's Fordo nuclear enrichment facility.
And Fordo is famous because it's not just a building on a military base. It is carved directly into the side of a mountain, buried deep underground.
Exactly. Intelligence estimated the Fordo facility was buried roughly 80 to 90 meters beneath solid rock and reinforced concrete. To try and neutralize it, the U.S. deployed B-2 stealth bombers carrying the GBU-57 MOP. That stands for Massive Ordnance Penetrator.
The Bunker Buster. I've seen footage of these things during testing. They are absolute monsters.
They are the absolute pinnacle of conventional, explosive, earth-penetrating weapons. A single MOP weighs 30,000 pounds. The B-2s dropped 14 of them during Midnight Hammer. And while the strike successfully collapsed ventilation shafts and caused massive surface damage, it exposed a chilling tactical reality.
Which is?
The MOP has a physical limit. Even with a hardened steel casing falling from a high-altitude bomber, the best conventional bunker buster in the world maxes out at around 200 feet or roughly 60 meters of penetration through solid rock.
But Fordo was 80 to 90 meters deep.
Precisely. And the adversaries of the world watch these strikes very closely. Following Midnight Hammer, intelligence services started noting that new subterranean facilities like the Pickaxe Mountain site mentioned in the text were being constructed deeper than 100 meters. They are pouring thicker concrete, designing angled tunnel entrances, and burying their command centers deeper than our best bombs can possibly reach.
So why can't we just build a bigger bomb, make a 60,000-pound bunker buster?
Because of how explosive energy works. When a conventional bomb, even one buried 60 meters deep, detonates, the chemical explosion expands spherically. The energy pushes equally in all directions, up, down, left, right. A massive percentage of that destructive force is wasted, blowing a hole back up toward the sky. It follows the path of least resistance.
It blows the roof off, but it doesn't push down into the floor. I see. But the tungsten rod from orbit doesn't explode? Doesn't have a chemical warhead?
Correct. And that changes the physics of the impact entirely. When that tungsten rod hits the mountain above the bunker at Mach 10, it doesn't create a spherical explosion. It takes all of that 11.5 tons of TNT equivalent energy and focuses it entirely onto a surface area of exactly 1 foot, the diameter of the nose of the rod.
That is an unbelievable amount of pressure localized on a space the size of a dinner plate. What happens to the mountain?
The physics cross over into fluid dynamics. At hypersonic impact speeds, the immense compressive force fundamentally changes the state of the matter it strikes. The tungsten rod doesn't just punch a hole through reinforced concrete and granite. The kinetic energy literally turns the rock and steel immediately ahead of the nose into a superheated, plasma-like fluid state.
Wow.
The rock ceases to act like a solid. The rod flows through the mountain like a hot nail driving through soft wax.
Like a hot nail through wax. That is a terrifying image. But the text points out that even a nail has its limits, right? Which brings us to an incredible piece of engineering described in the essay. Because as deep as that rod can go, it eventually stops. Why?
It's a problem known in structural engineering as shaft friction. If you picture driving a very long, thick nail into a dense block of hardwood, the first few inches go in relatively easily. But the deeper the nail gets into the wood, the more the surrounding wood fibers press inward against the sides, the shaft of the nail.
Right, the friction along the sides builds up. Eventually, it doesn't matter how hard you hit the nail with the hammer. The side friction is so great that the nail simply seizes up and won't go any deeper.
Exactly. That was the flaw of symmetry in the original 1950s Project Thor concept. The tungsten rod is perfectly cylindrical. As it drives into the earth, the liquefied rock and immense pressure clamp down on the 20-foot sides of the rod. The shaft friction becomes the dominant force, bleeding off all the kinetic energy. Models showed that a perfectly symmetric rod would stop after penetrating maybe 5 to 7 times its own body length.
So it would only penetrate 100 to 140 feet. Better than a bomb, but still not enough to reach a facility buried 150 meters deep. So how did they solve it?
The engineering fix is terrifyingly elegant. To eliminate the shaft friction, you simply break the symmetry of the weapon.
Break the symmetry. How? By changing the shape.
Not the outside shape. The rod remains a perfect cylinder on the outside. But internally, deep inside the nose cone of the tungsten rod, engineers place a small, dense weight slightly off-center from the central axis.
Wait, I'm trying to picture this. If you have an off-center weight in something falling from space, wouldn't that just make it tumble wildly out of control, like throwing a football with a rock taped to one side?
You would think so, but the key is how the rod is launched. The orbital platform doesn't just drop the rod, it fires it out of an electromagnetic railgun. And as it fires the rod, it imparts a massive rotational spin, thousands of revolutions per minute. It spins exactly like a rifled bullet or a perfectly thrown football spiral.
Okay, so it's spinning rapidly.
Yeah.
But what does that off-center weight do while it's spinning?
It invokes a physics principle called gyroscopic precession. Have you ever watched a child's spinning top as it starts to lose momentum? The very top of the toy doesn't stay perfectly vertical. It starts to trace a slow, tight circle in the air.
Yes, it wobbles in a circular motion.
That wobble is precession. Because the rod is spinning at thousands of RPMs, and because it has that tiny off-center mass pulling at the nose, the front end of the rod doesn't fall perfectly straight down. The nose traces a very tight, highly controlled, high-speed circle. As it falls through the atmosphere and strikes the Earth, the weapon is effectively tracing a cone shape.
Oh my God. So it's no longer acting like a nail being driven by a hammer.
Precisely. It becomes a Mach 10 drill bit.
Because the nose is sweeping in that tight, high-speed circle, it is physically cutting a hole through the rock that is slightly larger than the actual 1-foot diameter of the rod itself.
That is the genius of it. The precessing nose cuts a wider bore. Therefore, the 20-foot body of the rod passes through this newly excavated tunnel without ever touching the sides. The rock doesn't clamp down on it. Shaft friction drops to near zero.
It just glides through the hole it's cutting.
Without shaft friction, the effective penetration depth increases multiplicatively. The only thing slowing the rod down is the resistance at the very tip of the nose, not the sides. It can bore hundreds of meters into solid granite.
And the text points out that this spinning drilling motion solves another massive practical problem, which is oblique entry. Because mountains aren't flat. If you drop a regular symmetric rod onto the sloped side of a mountain, wouldn't it just glance off?
With a perfectly symmetric rod hitting an angled surface, you face asymmetrical pressure. The side of the nose that hits the rock first experiences massive resistance, while the other side is still in the air. That imbalance forces the tail of the rod to kick out. The weapon deflects, tumbles, and shatters against the mountainside without penetrating.
But the precessing nose fixes that.
It does, because the precessing nose acts exactly like the threads of a heavy-duty screw. When that rapidly spinning, circling nose hits the sloped rock, the cutting motion distributes the lateral forces evenly around the entire circumference of the impact point. It doesn't deflect. It actively bites into the angled rock, threading itself into the mountain, and physically pulls itself straight down along its intended vertical path. It doesn't bounce. It bores.
So we have an unstoppable, undeflectable Mach 10 drill bit falling from the sky, capable of reaching the deepest command bunkers ever constructed. If Jerry Pournelle thought of this in the 1950s, why didn't the United States build this during the Cold War? Why wait until the 2020s?
The answer is the same answer to almost every question in aerospace engineering. Economics. The economics of mortality. The physics of Project Thor were always sound. The barrier was gravity, and the cost of defeating it.
Let's talk about those costs. During the space shuttle era, and really up until the mid-2010s, putting mass into low Earth orbit was excruciatingly expensive.
It was prohibitive. During the space shuttle program, to put just 1 single kilogram of mass into orbit cost roughly $54,000.
And one of these tungsten rods weighs 12,000 kilograms, so that's what, nearly $650 million just to lift one rod into space?
Exactly. And a functional orbital strike platform requires a magazine of at least 6 rods to provide global coverage, plus the weight of the satellite bus, the solar arrays, the nuclear battery for the railgun, and the targeting sensors. If you ran the math during the Cold War, putting a single 6-rod platform into orbit would have cost somewhere between $4 and $5 billion for one satellite.
Yeah, that's steep.
The Pentagon looked at that and said, well, we can build a lot of nuclear submarines for $5 billion, so the project was shelved.
But the text highlights an economic collapse that has fundamentally changed the paradigm. And when we say collapse, we don't mean a depression. We mean a collapse in the cost of space launch. SpaceX and the era of reusable rockets changed the math entirely.
They didn't just change the math. They broke the historical models. When SpaceX proved that you could launch a massive orbital booster, land it back on a concrete pad, and fly it again a week later, the price to orbit plummeted. The Falcon Heavy rocket dropped the cost from $54,000 per kilogram down to about $1,400 per kilogram.
That is a staggering drop. But the author goes further. He cites the operational deployment of the Starship platform, the fully reusable super heavy lift vehicle. What are the projected costs under Starship?
The estimates cited in the essay place the cost of Starship payload delivery between $10 and $32 per kilogram.
$10 a kilo. From $54,000 to $10, that is a reduction by a factor of over 5,000.
And that is where the strategic nightmare begins. Let's do the fighter jet math because Enfield lays this out beautifully, and it is chilling. At Starship pricing, you can build a fully armed, nuclear battery-powered orbital kinetic strike platform, load it with 6 10-ton tungsten rods, attach the electromagnetic railgun, and put it in orbit for a total cost of somewhere between $210 million and $250 million.
If you're listening to this, I really want you to grasp that number. $250 million sounds like a lot of money to you and me. But in the context of the United States military budget, it is a rounding error. To put that in perspective, a single F-35 Lightning II fighter jet costs about $83 million.
Right. So for the cost of roughly 3 F-35 fighter jets, a nation-state can deploy an orbital weapon of mass destruction that can strike any point on the surface of the Earth in minutes.
And the essay brings up the concept of vulnerability versus immortality. Let's compare those 3 F-35 to the orbital platform.
An F-35 is a marvel of modern aeronautics. But it is profoundly vulnerable. It could be shot down by an advanced surface-to-air missile. Its radar and communications can be jammed by electronic warfare. It can be grounded because there is a severe thunderstorm over the airbase. It requires immense supply chains of jet fuel. And crucially, its pilot can be killed. Furthermore, an F-35 only operates in one regional theater at a time. It takes hours to fly from a base in Germany to a target in the Middle East.
But the tungsten rod?
The tungsten rod has no pilot to kill. It requires no jet fuel. It has no complex onboard computers or guidance fins that can be jammed by electronic warfare during its descent. It operates above the weather. And because it is in orbit, traveling at 17,000 miles per hour, It passes over every single point on the globe multiple times a day.
But surely, with modern missile defense systems, Patriot batteries, the Iron Dome, Aegis cruisers, we can shoot something down if it's falling from the sky.
You can try, but the physics are entirely against you. The text points out the timeline of an engagement. From the moment ground-based early warning radar detects the thermal signature of the rod re-entering the atmosphere, the target has exactly 11 seconds until impact.
11 seconds. You can't even pick up a phone and call the president in 11
You
seconds.
can't. And even if you had an automated, AI-driven hypersonic interceptor missile parked right next to the bunker and it managed to launch and hit the tungsten rod midair, what have you actually accomplished?
I mean, if two missiles hit each other, they explode, right?
But the rod isn't a missile. It isn't a hollow tube full of volatile rocket fuel. It is a solid 12,000 kilogram cylinder of the densest metal on Earth. If your interceptor hits it, you don't destroy the kinetic energy, you just fracture the mass. You take a single massive Mach 10 drill bit and you shatter it into a dozen smaller pieces of tungsten, all still traveling at Mach 10 toward the target.
Oh, man.
You haven't stopped the weapon. You have just turned a hypersonic sniper rifle into a hypersonic shotgun blast. The kinetic energy still hits the ground.
That is just bleak. You literally cannot defend against it. Which leads directly into the most legally complex part of this entire deep dive, the death of arms control. Because if I am listening to this, my immediate reaction is, this has to be illegal.
Yeah.
We have international treaties that govern space, don't we? The 1967 Outer Space Treaty, it explicitly bans placing weapons of mass destruction in orbit. 118 nations signed that treaty. How are rods from God not a violation?
This is where we encounter the most terrifying legal loophole in modern military history. You have to read the exact text of the 1967 Outer Space Treaty. It specifically prohibits the stationing of nuclear, biological, and chemical weapons in orbit. It bans prohibited substances.
Oh, I see where this is going.
Yes. The treaty says absolutely nothing about a metal pole. Legally speaking, under international law, a solid tungsten cylinder contains no explosives, no radioactive isotopes, and no biological agents. It is chemically inert. The satellite platform is legally classified as a communications and observation bus. The electromagnetic railgun is classified as a propulsion and deployment system, and the tungsten rod is merely a mass.
So because the weapon relies purely on physics, just gravity and velocity rather than chemistry or radiation, it bypasses the treaty entirely. Gravity is doing the killing, and you can't ban gravity.
Precisely. As of right now, deploying a kinetic bombardment platform is entirely 100% legal under international law.
And this loophole graduates from a theoretical problem to an existential global crisis when we look at a very specific date mentioned in the source material. February 5, 2026. What happened on that day?
On February 5, 2026, the New START treaty between the United States and the Russian Federation officially expired.
And for context, New START was the last remaining bilateral nuclear arms control treaty between the two superpowers, right?
It was the bedrock of global strategic stability. It capped the number of deployed nuclear warheads and, crucially, allowed for mutual on-site inspections of military bases and missile silos. But when it expired in 2026 without a successor agreement, those inspections ceased immediately. The 50-year era of nuclear transparency and strategic constraints simply evaporated overnight. The world entered a geopolitical vacuum.
So no treaties, no inspections, and incredibly cheap access to space. What does this convergence mean for the doctrine of mutually assured destruction? MAD is the concept we all grew up with. The idea that nobody launches a first nuclear strike because they know the other guy will launch a retaliatory strike and everyone dies. How do kinetic rods break that?
To understand how it breaks, we have to look at the two foundational pillars that make mutually assured destruction work. The first pillar is the second strike capability.
Which means your adversary won't attack you because they know they can't kill all of your leadership at once. They know your command bunkers are buried deep enough to survive the initial nuclear blast, allowing the surviving generals or the president to order the retaliatory second strike.
Exactly, the bunker ensures the retaliation. But as we just discussed, rods from God can penetrate deeper than the most advanced nuclear Earth penetrators. They can reach the subterranean facilities that were explicitly designed to survive the Cold War. They can reach Cheyenne Mountain in Colorado. They can reach the Raven Rock Mountain Complex in Pennsylvania. They make a conventional, non-nuclear decapitation strike entirely possible. The bunker is no longer a safe haven. Therefore, the guarantee of a second strike is compromised.
And the second pillar of MAD.
The second pillar is attribution. Deterrence only works if you know exactly who is attacking you. If a nation launches an intercontinental ballistic missile, an ICBM, early warning satellites in orbit immediately detect the massive infrared heat plume of the rocket motors.
Right. You can track the launch back to the exact silo in Siberia or the exact submarine in the Atlantic.
Yeah.
You know who fired it, and you have about 20 to 30 minutes to retaliate before the missile hits.
But an orbital kinetic platform doesn't have a massive rocket motor. When it is time to strike, the satellite simply opens a bay door and the railgun pushes the rod out. There is no massive infrared launch plume. There is no fiery ascent through the atmosphere. It simply detaches and begins to fall.
So the early warning satellites see nothing.
They see nothing until the rod hits the upper atmosphere and generates that plasma shock wave. And as we established, from that moment of radar detection, you have exactly 11 seconds until impact. Your leadership is buried under a liquefied mountain before an alarm even finishes sounding.
And even after the dust settles, you don't know who shot you.
Yeah.
By the time surviving military forces analyze the crater and try to back-calculate the orbital trajectory of the rod, it could take hours or even days to figure out which specific satellite dropped it. There are tens of thousands of satellites in orbit right now. It completely severs the link of attribution. It breaks deterrence entirely.
It is a weapon that is almost mythological in its power and its suddenness, which is exactly the pivot the author, Zachary David Enfield, makes next. He dives into the theological and mythological weight of this technology.
I found this section of the essay absolutely mesmerizing. The author draws these fascinating parallels, suggesting that ancient human cultures were essentially describing the architectural features of modern physics long before the math existed to build them.
It is a profound observation. He looks at ancient texts across various cultures. Take the Sanskrit epics and the Brahmastra, which was considered the ultimate weapon of divine judgment in Hindu mythology, or look at Zeus's thunderbolt in Greek myth, or Thor's hammer, Mjolnir, in Norse legend.
Right, in all of these stories, the ultimate power is never a sword swing or an army marching horizontally across a field. The ultimate power is always a vertical strike descending from the sky.
Exactly. The ancient texts describe an absolute, unchallengeable power that descends from the heavens. It makes the earth barren. It cannot be blocked horizontally by any shield, any wall, or any human army. Enfield argues that these ancient writers weren't just imagining magic, they were intuitively describing the structural realities of absolute destructive power.
And then there's the biblical text he cites, Revelations 6.15-17. It gave me chills reading it in the context of space weapons. The text reads, "Then the kings of the earth, the princes, the generals, the rich, the mighty, and everyone else, both slave and free, hid in caves and among the rocks of the mountains. They called to the mountains and the rocks, 'Fall on us and hide us from the face of him who sits on the throne and from the wrath of the Lamb. For the great day of their wrath has come, and who can withstand it?'"
When you view that text through the lens of 2026 aerospace engineering, it ceases to be a metaphor and becomes a stunning architectural reality. Think about who hides in the rocks of the mountains today. Modern leaders, the kings and the generals, literally hide inside mountains like Cheyenne Mountain.
And the terror described in that passage from Revelation. It isn't fire raining from the sky. It isn't a nuclear mushroom cloud.
No. The psychological terror is the sudden realization that the mountain they thought would protect them isn't thick enough. They are sitting hundreds of feet deep inside the rock, praying for the mountain to cover them. And then the kinetic rod arrives in total silence. It drives the very rock of the mountain down on top of them. The bunker they built for survival becomes their tomb.
It arrives in silence. Because it's traveling at Mach 10, it's moving vastly faster than the speed of sound. You would never hear it coming, just sitting in a bunker, nothing, 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 and then the mountain liquefies. The author connects this existential dread to the Hebrew root of the word Israel, doesn't he?
He does. The word Yisrael roughly translates to one who struggles or wrestles with God. It refers to the biblical story of Jacob wrestling a divine entity in the dark by a river all night, limping away but ultimately surviving. Enfield uses this as an epistemological framework for humanity in the 21st century. We are a species constantly wrestling with a power we don't fully understand. We discover splitting the atom, we build a weapon, we get terrified, we write a treaty to contain it. But then the technology outpaces the treaty. Launch costs collapse. And suddenly we find ourselves right back in the dark, wrestling at the river, desperately hoping we survive until the morning.
That is a deeply sobering philosophical framing. But if we connect this to the bigger picture, here is where the deep dive takes a massive 90-degree turn. This is the pivot. Because everything we have talked about so far, the tungsten rods, the orbital railguns, the Mach 10 impacts, the shattering of nuclear deterrence, all of it has a dual-use dilemma. If you print this machinery down at the Earth, it is the ultimate weapon of decapitation. But if you point it outward at a dead world, it becomes the ultimate tool for planetary engineering.
This is the premise of Enfield's second essay, The Centennial Collapse. He argues that the exact same physics that can destroy a bunker can terraform a planet, and his target is Venus.
Venus, not Mars. Everyone always talks about terraforming Mars. But Venus is an absolute uncompromising hellscape right now. I think people forget just how hostile it is.
Hostile is an understatement. The surface temperature of Venus is roughly 450 degrees Celsius, which is hot enough to melt lead. The atmospheric pressure at the surface is 92 times greater than that of Earth. It is the equivalent of being a kilometer deep in Earth's oceans.
Wow.
And that crushing atmosphere is 96.5% carbon dioxide, laced with clouds of sulfuric acid. Traditional terraforming models, the ones debated by planetary scientists for decades, usually conclude that it would take millennia, tens of thousands of years just to cool the planet down.
But Enfield's model says we can do it in 100 years, 1 century. He proposes triggering a multiplicative cascade using 6 integrated massive technological systems. He calls it the 6-system symphony. I want us to really take our time here and break down each of these 6 systems because the science is mind-bending. Let's start with System 1, the orbital mirrors.
The first step in taming Venus is getting control of the solar radiation. System 1 calls for the deployment of 40,000 massive mirror elements placed at the Venusian L1 point.
Okay, stop right there. What exactly is an L1 point?
In orbital mechanics, a Lagrange point, specifically L1, is a gravitational sweet spot in space between 2 large bodies, in this case the Sun and Venus. At the L1 point, the gravitational pull of the Sun and the gravitational pull of Venus perfectly cancel out the centripetal force required for a small object to move with them. It essentially allows a satellite or a mirror to park in space, constantly staying directly between the planet and the Sun.
So you park 40,000 mirrors there to just cast a giant shadow over the planet.
Not over the whole planet. The mirrors are angled to specifically cast a deep shadow over one of the poles, drastically cooling it down. This creates an artificial cold trap where the atmospheric carbon dioxide can eventually freeze and precipitate out as dry ice snow. But simultaneously, the system deploys 10,000 parabolic mirrors to focus and superheat the opposite pole.
Wait, why would you want to heat up a planet that is already melting lead?
To create a thermal gradient. If you make one side of the planet freezing cold and the other side insanely hot, you generate an artificial temperature difference of roughly 1,500 degrees Celsius across the globe. Physics dictates that the atmosphere will desperately try to equalize that pressure difference. This artificial gradient whips up massive planetary scale winds. We are talking about continuous gales of 500 meters per second.
That's over 1,000 miles an hour.
Exactly. It creates a violent, continuous mixing of the stagnant Venusian atmosphere. The mirrors provide a continuous energetic forcing so the atmosphere can never settle back into its stable, hellish equilibrium.
Okay, so you have super hurricanes scouring the planet. That brings us to System 2, which involves nukes. The text mentions Territon nukes. I thought we were trying to build a planet, not blow it up.
It sounds counterintuitive, but it's about shifting mass. The essay calls for the deployment of 1,000 gigaton fusion devices. To give you some historical context, back in the 1950s, Edward Teller and the scientists at the Lawrence Livermore National Laboratory modeled the feasibility of 10 gigaton nuclear devices under something called Project Sundial. They proved the physics were sound, they just had no practical use for a bomb that big on Earth.
So modern engineering allows us to scale those Cold War designs up infinitely. A 1,000 gigaton bomb is a 1 teraton device. What does an explosion of that magnitude even look like?
A 1 teraton device releases roughly 1/10 the kinetic energy of the Chicxulub asteroid, the asteroid that wiped out the dinosaurs.
We are detonating dinosaur-killing nukes on Venus. That is insane. Wouldn't that just blow the planet apart?
It would cause unimaginable devastation on Earth, yes. But remember the Venusian atmosphere, it is 92 times thicker than ours. It is more like an ocean of gas than an atmosphere. The model dictates detonating these teraton devices in the middle atmosphere at altitudes of 50 to 70 kilometers. Because the gas is so incredibly dense, the detonations don't just blast harmlessly out into space. They create what the author calls atmospheric earthquakes.
Atmospheric earthquakes.
The shock waves from these teraton blasts circle the entire globe, triggering massive convective upwelling. It violently churns the ocean of CO2, physically lifting the heaviest, lowest layers of the atmosphere up to higher altitudes where it is thinner and can eventually escape into space.
Wow. Okay, so we have 1,000-mile-an-hour winds and nuclear atmospheric earthquakes. That brings us to System 3, which is where our old friends, the rods from God, make their return. Kinetic bombardment. But the essay notes they use 4-ton variants instead of the massive 10-ton bunker busters. Why drop a million kinetic rods onto Venus? What are we trying to destroy?
We aren't trying to destroy anything. We're using the kinetic rods as a planetary scale tiller, like a farmer plowing a field. The biggest problem on Venus is the carbon dioxide. You have to get rid of it. If you smash 1 million kinetic rods into the Venusian crust at hypersonic speeds, the impacts excavate millions of tons of fresh, unweathered rock from deep underground. Specifically, it brings up calcium and magnesium silicates.
And why do we care about silicates?
Because of the chemistry of carbon sequestration. When this fresh, pulverized silicate rock is suddenly exposed to the dense, hot CO2 atmosphere, a rapid chemical reaction occurs. The silicates bond with the carbon dioxide, transforming the gas into solid carbonate rock.
Wait, so the rock literally sucks the gas out of the air and turns it into stone?
Yes. It is brute force, hyper-accelerated geological weathering. Every rod that hits the ground exposes more rock, which sucks more carbon out of the atmosphere, locking it safely away in the crust.
That is brilliant. Okay, moving on to System 4. Laser arrays. The text says we put 50 orbital platforms in space, firing high-energy free electron lasers down into the atmosphere. What is a free electron laser and what is it shooting at?
A free electron laser uses a particle accelerator to generate a beam of coherent light. They are highly tunable, meaning you can set them to emit light at very specific, incredibly precise wavelengths. The problem with the carbon dioxide molecule is that it is incredibly stable. It doesn't want to break apart. But if you tune these orbital lasers to the exact resonant frequency of the CO2 molecular bonds, the laser light causes the molecules to vibrate so violently that they shatter.
Ah, I see. The essay uses the term photodissociation. Is that what that means?
Exactly. The photons from the laser physically break the chemical bonds, splitting the carbon dioxide into carbon monoxide and oxygen radicals. This forced dissociation opens up entirely new, exotic photochemical pathways in the atmosphere. It creates new compounds that help degrade the runaway greenhouse effect much faster than natural processes would allow.
So we are shooting lasers at molecules to break them apart. Incredible. Now, System 5 is probably the weirdest one to me. Acoustic resonance. 20 platforms generating giant low-frequency sound waves. The author calls it organized chaos. How does sound help terraform a planet?
Think about all the energy we have just pumped into this planet. Thermal gradients, teraton nuclear shock waves, kinetic impacts. The atmosphere is in a state of chaotic, violent turbulence. But chaos is inefficient. Acoustic resonance uses the science of cymatics. If you pump massive, continuous, low-frequency sound waves into a fluid medium like the dense Venusian atmosphere operating at the resonant frequency of the planet itself, the sound waves organize the turbulence.
It organizes it, like sand forming geometric patterns on a vibrating metal plate.
Precisely like that, but on a planetary scale. These acoustic standing waves create massive, invisible, stable structures in the atmosphere. They act like giant chimneys. They shepherd all that upwelling gas from the nuclear blasts, organizing the chaotic thermal energy and channeling the atmospheric flow directly toward the high-altitude escape zones at the poles. It acts as a structural scaffold made entirely of sound.
A scaffold made of sound to vent an atmosphere. My mind is officially blown. And that brings us to the sixth and final system, which isn't actually a piece of hardware, it's the cascade itself, the multiplicative effect.
This is the crux of the Centennial Collapse model. These 5 systems, the mirrors, the nukes, the rods, the lasers, and the acoustics, don't just add their effects together linearly, they multiply each other's effectiveness. The mirrors create the winds carry the freshly excavated rock from the kinetic strikes to maximize carbon absorption, the nukes lift the lower gas up to where the lasers can photodissociate it, and the sound waves organize the whole chaotic symphony into an efficient engine.
And the essay sets a very specific timeline for this. It mentions the year 30 threshold. What happens at year 30?
The timeline is critical to understanding planetary engineering. For the first 30 years, humanity is constantly pushing the planet. We are forcing energy into the system, and Venus is actively fighting back, relying on its massive thermal inertia to try and return to its stable, hellish equilibrium. It is a war of attrition between human engineering and planetary physics. But the math shows that at exactly year 30, a threshold is crossed.
The planet's internal feedbacks reverse.
Exactly. The temperature drops just enough, the pressure drops just enough, that the runaway greenhouse effect collapses. Venus stops fighting the terraforming process and actually starts actively participating in its own transformation. The natural planetary systems begin accelerating the cooling.
The cascade takes over. And according to Enfield's math, by year 100, the results are staggering. The surface pressure is down by 45%, the temperature drops by 130 degrees Celsius. He even predicts that actual physical ice caps will form at the poles. Now, to be clear, at year 100, it's still not Earth. You can't just walk outside in a t-shirt. But it is a proto-habitable world. It's a place where a shielded rover wouldn't melt in 5 minutes. So the ultimate question, what does it cost to build a world from scratch?
The author runs the amortization tables. To build the mirrors, launch the kinetic platforms, deploy the lasers and the acoustics, and maintain the system for a century, the total bill is estimated at $1 trillion. Amortized over the 100-year timeline, that breaks down to $100 billion a year.
$100 billion a year. Let's put that in real-world context for our listeners.
Yeah.
Because that sounds like an impossible amount of money.
It's actually a surprisingly manageable sum on a geopolitical scale. $100 billion a year is roughly 0.1% of the current global gross domestic product. It is approximately equal to the current combined annual budget of NASA and the European Space Agency.
But yeah, I want to emphasize a different comparison from the text because it hit me like a ton of bricks. $100 billion a year is less than what the United States currently spends just maintaining its nuclear weapons arsenal, not building new ones, just paying the upkeep on the bombs we already have. We currently spend more money every single year preserving the capacity to destroy our world than it would cost to build a brand new one next door.
It is a staggering reflection of human priorities, and it leads directly to the final, profound philosophical point of the deep dive, Enfield's concept of giving to God.
Yeah, let's unpack that. Because despite all the talk of weapons and treaties, the essay ends on an incredibly poignant, almost spiritual note about the purpose of technology.
Enfield argues that this magnitude of technology, the ability to literally move mountains, to release teraton energies, to alter the atmospheres of celestial bodies, has what he calls a prior claim on the human spirit. He points out that when ancient scriptures talked about having faith the size of a mustard seed to move a mountain, they weren't just speaking in poetic metaphors. Moving a mountain was always a physics problem. It was just waiting for human engineering to catch up to the vision.
And now we have caught up. We have the math. We have the reusable rockets. We have the tungsten.
Right. And his argument is that this technology should not be captured by kings, generals, and politicians to build better bunkers, or to execute decapitation strikes in the Middle East, or to enforce the petty borders of Earth. The technology is too big for that. It should be dedicated to the covenant of life and the expansion of the human species. It should be, in his words, given to God.
It brings us right back to where we started. Think back to that packet of Kool-Aid in Hastings, Nebraska in 1927. You concentrate potential. You strip away the excess. You build a system of perfect, deliverable energy. But physics does not have a moral compass.
Physics is entirely agnostic.
Physics does not know the difference between a Martian ice cap, a Venusian volcanic basin, and an underground command bunker in a war zone. It is just gravity, mass, and velocity. The only variable that changes is human intent. Only the human heart knows the difference between a weapon of mass destruction and a planetary engineering tool.
It is the ultimate expression of the dual-use dilemma. It is the exact same orbital platform, the exact same Starship launch costs, the exact same Mach 10 re-entry physics. The only thing that changes is the direction we point the rod and the moral framework of the species making the decision.
So, to summarize this incredibly dense, awe-inspiring journey we've taken today, we started in a humble kitchen in Nebraska with Edwin Perkins mixing up fruit powder. We trace that foundational logic of concentrated potential to the massive, sprawling naval ammunition depot hidden in the prairie grass. We followed that logic up into low Earth orbit with Jerry Pournelle's Cold War vision of Project Thor. We looked at how SpaceX and the era of reusable rockets collapsed the cost of spaceflight, inadvertently creating a massive legal loophole in the 1967 Outer Space Treaty and bypassing the expired New START nuclear pact. We explored how a Mach 10 precessing tungsten drill bit can liquefy the deepest bunkers on Earth, fundamentally breaking the doctrine of mutually assured destruction. And finally, we saw how that exact same kinetic technology working in a symphony with orbital mirrors, Terran atmospheric earthquakes, and acoustic resonance could resurrect the dead planet of Venus in just a single century.
It is a breathtaking synthesis. It weaves together the coldest, hardest realities of orbital mechanics and material science with the deepest geopolitical anxieties and the highest aspirations of planetary engineering.
It really is. I want to ask you, our listener, to do something tonight. When the sun goes down, go outside, look up at the night sky, and try to spot a satellite moving across the stars. Consider that the line between a weapon of absolute divine judgment and the tool that unlocks our future in the solar system is razor thin, and entirely up to us to navigate.
That's a powerful thought to end on.
Well, before we sign off, I want to leave you with a final, provocative thought to mull over. Something that builds on Enfield's text, but extrapolates a step further into our immediate future. The source material noted that the collapse in space launch costs means that nation-states aren't the only ones who can afford this technology anymore. Corporations, private military contractors, or massive sovereign wealth funds will soon be operating heavily in orbit. They will explicitly need mass drivers and kinetic impactors for legitimate commercial purposes, like asteroid mining or laying the groundwork for off-world colonies. But consider the implication of that dual-use reality. As humanity expands into the solar system, utilizing mass drivers to move asteroids and dropping kinetic impactors to build new worlds, every single commercial space colony inherently possesses a weapon of mass destruction.
That is a deeply unsettling extrapolation, but a mathematically sound one.
Think about it. If a private corporation or a mining guild has the industrial capacity to drop a 4-ton rock on Venus to terraform it, they inherently possess the exact same capacity to drop a 10-ton rock on Earth. In the near future, avoiding World War IV won't just be about managing a handful of superpowers with nuclear launch codes and red telephones. It will be about trusting every single commercial corporation, every asteroid mining guild, and every independent space colony in the solar system with the literal power of gravity itself. How do you regulate a weapon of mass destruction when the WMD is just a rock and gravity and suddenly everyone has access to the ultimate high ground?
It implies that the wrestling at the river that struggle to govern our own destructive potential is never going to end. It doesn't get solved by moving to space. It just scales up to the size of the solar system.
It just scales up. Thank you so much for joining us on this deep dive into the architecture of the unconstrained sky, the physics of judgment, and the blueprint for new worlds. Keep looking up, keep asking the big questions, and we will catch you on the next deep dive.